So hello. So today's topic fields and the subject is the introduction of petroleum engineering. So let's move on. So our team. So Kudaybergenov Azamat, could you please introduce yourself?
Yes, hello everyone. I am Oseberg Oseberg. Uh, it's my first year, and with my partner Rowan, we would like to talk about the Oseberg oil and gas field.
Okay. So my name is Circle One. It's my first years of KB2. And so let's move on. So our contents. So first, I will talk about Oseberg, and the next properties of the fields, production mechanisms used, and the criteria for productions. Also, the air methods used Oseberg fields will tell about Azamat, and also um, Oseberg platform. So Oseberg platform is like divided on the like A, B, C. So first, Oseberg A is a concrete platform, so which is located Norway, North Sea, northwest of Bergen, Norway. So it's a concrete platform with a process equipment and a living quarters. And while Oseberg B has a steel jacket and the drilling, production, and the injection equipment. So Oseberg B is the gas processing and the export equipment. So it's a steel platform with the gas processing and the export equipment. It was connected to the field center with a bridge in the spring of the 1999 of years. And so Oseberg C is the processing and the drilling platform is like main platform, which is like um uh which is um like drilling, and which is have the drilling bit is a modern cost-effective wellhead platform with a steel jacket. Oil and the gas are transported in a multi-phase pipeline from the Oseberg Sea in the Oseberg Field Center. So next presentation will tell about Azamat.
So I will talk about the physical properties of the uh, Oseberg oil and gas field. The formation of the oil and gas field, it consists of sandstones. It was deposited in the since the Jurassic period, and it has 50 to 100 meters in thickness. And this Oseberg formation exhibits similar characteristics to the Stratford formation, and it has a porosity ranging from 15% till 25%, and permeability from 50 till 500 millidarcies. And depth and the pressure and the Oseberg oil and gas field reservoir are located at depths ranging from 2,000 till 3,000 meters, and it has reservoir pressure range between 3,000 and 5,000, and the temperature in the oil and gas field is ranges approximately between 70 and 120 Celsius degrees, and these temperatures are influenced by depth and the geometrical gradients and thermal properties of the formation. And porosity of the oil and gas field uh, exhibits the 15 and 30%. It indicates that significant pore space available for fluid storage, and the permeability is ranges from 50 till 500 millidarsals, and the variation in permeabilities influence the fluid flow rates and the distribution within the reservoir, and the fluid composition of this crude oil is characterized by API gravity. So it is from 27 and the 38 degrees, and this crude oil has low viscosity, and it has easier flow, and contributes to the recovery rates. And in this oil and gas field, we have associated gas, which is natural gas in various crude oil composition. And but generally, the associated gases are ethane, propane, uh, and a small amounts of heavier hydrocarbons. And the range is typically between 500 and 2,000 cubic feet per barrel. And the fluid mobility, water saturation within the reservoir ranges from 10 till 30%, and the gas saturation ranges from 20 and 40%. And reservoir pressure in the field uh, average declines from 100 till 200 PCI per year due to the fluid production. And in this oil and gas field, they use management techniques such as gas and water injection to mitigate the depletion effects and optimize the hydrocarbon recovery. And also the adjustment of injection rates is performed to maintain the reservoir's pressure within the optimal range of production. The next slide. So here is given geographical structure of the Oseberg oil and gas field. Uh, this oil and gas field structure uh, has sandstone reservoirs, uh, which holds many oil and gas reservoirs. And these sandstones, they act like as an sponges. They trap the hydrocarbons within. And this geographical structure is located in the North Sea. It means that it has bumps and folds and cracks within the rock layers, uh, which can affect the oil and gas trapment and their movement. And beneath the sandstone, we have reservoirs. They are different kind of layers, type of rocks, like shale and limestone. And these layers can impact how easily the oil and gas can flow. In the above the layers, reservoir layers, we have a rock, which act as a caps, which can prevent the gas and the oil from leaking out. These layers usually made of impermeable rocks, like shales, and over a million of years, and the oil and gas migrated from the source rocks to the sandstone reservoir, and understanding how they formed and how they moved uh, help us to find out the oil and gas location. By studying this type of rocks and fossils found in this area, the scientists, the engineers can learn about how the rocks are formed, uh, and which can help us to uh, understand how the reservoirs were created and how they might behave or move. So in this structure, we have porosity and permeability ranging from 15 till 30%, and till 50 and 500 millidarcels. And the heterogeneity of the Oseberg field uh, is range from 5 and to 20 meters, and the porosity varies from 15 till 25%. The next slide. Um, so in the uh, primary production, the oil and gas flow naturally from the reservoir due to the existing pressure within the rock formation. and these wells drilled into the reservoir, and the pressure differential between the reservoir and the surface allows the hydrocarbons to flow to the wellbore and then to the surface and facilitates for the processing. And as the reservoir pressure naturally declines over the time due to the production, and the primary production becomes less effective, leading to the need for secondary and the other recovery methods. The next slide. Water injection method, which is commonly used in the secondary recovery method, is used in many mature oil fields, which includes the Oseberg oil and gas field. And the water often sourced from the seawater or treated produced water is injected into the injection well and is strategically placed around the perimeter of the reservoir. The injected water helps to maintain the reservoir pressure and displaces the oil towards the production wells and sweeps the residual oil towards the production wells that might have been bypassed during the primary production. And also water injection can also help to mitigate the reservoir pressure, thereby extending the productivity life of the oil field. The other method is gas injection. It involves injecting the gas, typically natural gas or other associated gases produced from the reservoir, and into the reservoir. We use the gas injection to maintain the pressure and improve the oil recovery. And it is similar to the water injection, and the gas injection helps to displace the oil towards the production wells and maintain the reservoir pressure. And additionally, gas can dissolve in the oil and reduce its viscosity and making it easier to flow towards the production wells. And the artificial lift methods are employed in wells where reservoir pressure is insufficient to lift the oil and to the surface. So we use electric submersible pumps, uh, and it's powered by electricity. It is used to lift oil from the wellbore to the surface. And these ECPs are suitable for deep wells and those with high fluid viscosity. And the gas lift involves injecting the gas into the wellbore to reduce the density of the fluid column and allowing the reservoir fluids to flow more easily to the surface. And this method is very versatile and is suitable for various well conditions and can be adjusted to optimize production rates. The next slide. Um, so criteria for production for the Oseberg oil and gas field is consists of well configuration and the reservoir characteristics, drilling and completion, and the recovery factor. Well configuration, placement, completion techniques, and the artificial lift methods to maximize the production and the rates of the ultimate recovery rate, and to minimize the operational costs. And the reservoir characteristics, it is to understand the geological properties of the reservoir. It includes the porosity, permeability, and the fluid composition, and the reservoir pressure, and to determine the most suitable production techniques and the technologies for the production. And the drilling and completion technologies, they utilize the advanced drilling and the completion, such as horizontal drilling and multilateral wells and the smart completions and the sand control methods. produce the hydrocarbons from complex reservoirs efficiently. And the recovery factor is to evaluate the current recovery factor and identify the opportunities to increase uh, through the enhanced production. Uh, in this method, we use secondary and tertiary recovery methods. The next slide. And and uh, in this EOR method used in the Oseberg field, uh, um, this enhanced oil recovery method. Uh, and these techniques, they're advanced methods which is employed after the primary and the secondary recovery stages to increase the oil recovery. And this steam injection involves injecting the steam into the reservoir to heat the oil and reduce the viscosity, and makes the liquid flow towards the production wells. And this method is particularly useful for heavy oil reservoirs uh, on the polymer flooding. For example, utilizes the injected polymer to improve the sweep efficiency of injected water and displacing more oil towards the production wells. And the EOR techniques are often tailored to the specific characteristics of the reservoir and significantly enhance the ultimate oil recovery. Uh, uh, and that's it. The next slide. And here, given the gas injection method for the Oseberg oil and gas field, uh, it has two primary gases considered for the injection, which is natural gas composition, which is 85 and 95% methane, along with ethane, propane, and other hydrocarbons. And the typical composition ensures the compatibility with the reservoir fluids. And the carbon dioxide purity, which is carbon dioxide purity levels for injection purposes typically exceeds 95% to ensure the effectiveness in enhancing oil recovery. And the injection method is gas injection involves the injecting gas into the reservoir through the dedicated injection wells and the strategical located across the field. And the process is non-miscible and the gravity stable gas displacement and a very low residual oil saturation at the gas swept zones. The next slide. And the Oseberg gas injection from the troll accelerates and increases the oil production on Oseberg. And the troll has been injected to the Oseberg field in the period of 91 until 2002. And as the injected troll gas will be reproduced and exported together with the Oseberg gas. Injection rates is typically from 10 till 50 million standards cubic feet per day, and natural gas is 5,000 till 20,000 tons per day. And gas recycling efforts is made to recycle the produced gas for injection purposes to reduce the gas flaring and minimize the environmental impact. And this method is used in the Oseberg field to optimize the reservoir performance and maximize the hydrocarbon recovery and extend the economical life of the field, and ensuring the environmental sustainability and the regulatory compliance. The next slide.
So thank you, Azamat. So my part is a criteria for the error methods. So I will tell about the criteria. So first is the reservoir fuels properties. So is the analyze the fluid and the properties such as the viscosity and the API gravity. So reservoir pressure and the chemical composition to select the error methods. And the sets can effectively displace and recovery trapped hydrocarbons. So next is reservoir characteristics. So understand the geological and the petrophysical properties of the reservoir, and including the porosity and the permeability and the fluid type, and the what type of heavy oil, light oil, and the viscous oil, um, and the reservoir depths and the heterogeneity to assess the feasibility and effectiveness and the different error methods. So third one, the technological maturity. So consider the maturity and the prevent track water flooding and the gas injections and the carbon dioxide or natural gas, and there's like chemical flooding like polymer surfactant, and like thermal methods, steam injection, and the microbiological air methods in the similar reservoirs or geological settings. So next slide is the integration of the latest technologies for the error in the future. So chemical error methods like polymer and the surfactant injections. So polymer flooding and the surfactant injection as chemical error methods that alter the fluid's properties to improve the sweep and sweep efficiency and the displacements of the oil. And in laboratory experiments and the pilot tests can determine the effectiveness of these methods in the Orbix field reservoir conditions. Um, so the thermal air steam injection. So thermal steam injection is like thermal air methods in reservoirs with heavy or viscous oil, which is use the thermal injection. So um, steam injection can be reduce the oil viscosity and improve the mobility of the oil. And assessing the reservoir temperature and the fluid property is necessary to design steam injections uh, projects effectively. So microbial air methods. So microbial air methods involves the injecting the microorganisms into the reservoir to enhance oil recovery through the mechanisms such as the biodegradation of heavy oil components or generation of biosurfactants and like researching and the pilot projects and like some laboratory experiments can explore the applicabilities of microbiological methods is like in the Oseberg field. And so next is innovation technologies. Is innovation technologies continuously evaluate and adopt innovative technologies such as smart wells and real-time monitoring systems and advanced reservoir characterizations techniques to optimize the air methods operation and improve the decision making. So it's like first is innovation like technologies for the controlling the process and controlling the drilling rig, in the um, for the increasing the um, securities and the safeness of the process. And so combined with the error methods, so combining different error methods such as combining water and gas injection, or integrating the chemicals and the thermal methods can uh, uh, increase the oil recovery. So integrate the reservoir modeling and the simulation studies can optimize the design and the implementation of the combined with the air strategies. And with the combination with the two methods or three methods, can the um, successing the improving the process, and with like water with gas injection, with we can combine the uh 50-50, approximately 50-50 water and the gas injection to improve the oil recovery, and uh, to decrease the oil viscous, and the integration of advanced technologies to ensure uh, 100% safeness on the platform. So thank you for the attention. Goodbye.